All right, example 7. Graph f of x equals absolute value of x minus 1. State the domain and range of the function. Also identify the intervals over which the function is increasing and decreasing. Now, it does ask us to graph it. I'm going to say graphing for a moment. I'm going to talk about domain first. You do not have to graph to get domain. Domain's all about restriction. And what's happening in this function is we're subtracting 1 from x. So the first question you have to ask yourself, is there some number out there that subtraction by 1 is bad? Is there any number out there that I can't subtract 1 from? Anybody name that number? Absolutely not. Is there any number out there that if it was negative I can make it positive, or 0 I can keep it 0, or positive I can keep it positive? Any number out there that changing the sign from negative to positive or keeping it positive, that bad things would happen whatsoever? No. So, the domain of this is all real numbers. All right. So, can I subtract from one from everything? Absolutely. Can I take any number and make it positive? Absolutely. There's no restriction on an absolute value function or a subtraction function. Okay. So the domain of this is a set of all real numbers. We start off there. Domain helps us to pick the x values we can graph with, right? So at this point, it's not restricting me at all. I can pick anything I want to. I can pick 75 or 12 or -4. It doesn't matter what I pick. But if I'm graphing an absolute value function, going back to our last section, I recommended that we pick whatever makes this equal to 0, right?
1.
Okay, what makes that 0 is 1. So if I was to graph this function, I'd want to make sure that I pick the number 1, because 1 minus 1 is 0. The absolute value of 0 is 0. I'd also want to pick numbers near 1 because those are easy. So 0 and -1 and 2 and 3 are all near 1. In each case I'm going to subtract 1, make the result positive. So -1 minus -1 is -2, make it positive, it's 2. 0 minus -1 is -1, make it positive. 2 minus 1 is 1, keep it positive. 3 minus 1 is 2, keep it positive. So we get this nice list of numbers.
So that's
-1, 2, 0, 1, 1, 0, 2, 1, 3, 2. Just our basic absolute value graph. It makes straight lines going up like so in a V shape. All right. Domain is all about restrictions on the function. It's all about what x can be. All right. It's all about, is there division, is there square roots, that kind of stuff happening. This had no restrictions, so all real numbers could be used. We picked a few numbers to create the graph, and we assumed the rest of the graph going to both infinities, right? So, range. Range is about the y values. In this case, notice it says graph f of x. It doesn't say y, it says f of x. This should actually be an f of x here instead of a y. All right. The y variable here is f of x. All right. Range is about f of x. Where does f of x start? Like the graph here, where's the lowest point on the graph?
0.
Right here is the lowest point, right? What's the highest point? Infinity. It goes up to infinity. So it starts at 0 and goes all the way up to infinity, either here or there. It doesn't matter which one it goes to. They're both going to infinity. All right? So the range describes y. And what I'm seeing for the range, I'm going to put r equals the set of all f of x such that. Okay, I want to describe what that graph shows me. So what does that graph show me? That y starts where and goes to where?
0 goes to infinity.
Starts at 0, goes to infinity. 0 has a closed circle on it, right? So it's equal to 0. So I'm going to say f of x is greater than or equal to 0. Okay, it's just basic inequality. That's saying that the answer, and I can pick any number I want to put in for x to get this, the answer is going to either be 0 or bigger. That's all range is. All right, and the final thing here, it says identify the intervals over which the function is increasing and decreasing. Okay, so here I want I want to paint a mental picture for you here. We're driving in a car. We're going to start at x equals negative infinity. We're going to end our trip at x equals positive infinity. It's going to be a long trip. Okay? If I'm driving, I always drive from here to there. We always drive in this direction. Okay? If I'm driving and I'm going down a hill, the function is decreasing. If If I'm going up the hill, the function is increasing. If it's flat, that's a constant. It's not increasing or decreasing, okay? Looking at this function, it decreases all the way till when? Y equals 0, what does x equal? 1. All right. So in our trip, when we identify intervals, we're all about x. Okay, where's x going? So increasing and decreasing, and we're identifying intervals. We always use parentheses on these intervals. There's never a bracket because we don't have an increasing or decreasing in a specific value. Okay? So it's increasing starting at 1 and going to infinity. It's decreasing starting at negative infinity going to 1. Because again, if I start my trip here, I'm going downhill until I get to x equals 1. Then I'm going uphill until I get to x equals infinity. These intervals are about x, not y. Okay? Increasing and decreasing is about y. We're going down, we're going up. Y's already been taken care of. What's x doing in those intervals? All right, so from x equals this to this is going down. From x equals this to this is going up. So that's what these intervals are always about. The x value, not the y value.